That night, Waikiki felt like a cinema. Families climbed onto hotel rooftops with lawn chairs and cameras. The local papers had promised a spectacular display in the sky. Some people brought their kids, others brought cocktails. At 11 p.m., the countdown reached 0. And nothing exploded on the horizon. Instead, something far stranger happened. The stars went white. Then the sky turned green. And finally, a blood-red halo spread across the Pacific, hanging over Hawaii like a silent wound. Streetlights flickered. Alarms went off. A telephone link between the islands suddenly died. No thunder, no mushroom cloud. Because this bomb hadn't gone off in the air. It had gone off in space. This is the story of Starfish Prime, the nuclear test that lit up the sky, fried satellites, and accidentally changed our understanding of both war and the planet itself. You've probably heard about nuclear tests in deserts and atolls, mushroom clouds, shock waves, radioactive dust. Starfish Prime was different. On July 9th, 1962, the United States launched a Thor missile from a tiny island in the Pacific called Johnston Atoll. 13 minutes later, a 1.4 megaton thermonuclear warhead detonated 400 kilometers above the Earth, high above the central Pacific. No crater, no blast wave you could feel. But the invisible effects reached more than 1,400 kilometers away, all the way to Hawaii, and even further into Earth's magnetic field and the orbits where our first satellites were just starting to live. It was meant to be a test. Instead, it became a warning. To understand Starfish Prime, you have to go back a few years. In the late 1950s, the United States and the Soviet Union briefly agreed to a kind of unofficial pause in nuclear testing. Both sides had more bombs than they could ever use, and scientists were worried about fallout in the atmosphere. But in August 1961, the Soviets broke the moratorium. They resumed massive tests, including the infamous Tsar Bomba, the largest nuclear weapon ever detonated. In Washington, President John F. Kennedy was under pressure. The Pentagon wanted to know, could a nuclear explosion high above the atmosphere blind enemy radars? Could it fry the electronics on incoming missiles? What would it do to radio communications? And to the newly discovered Van Allen radiation belts surrounding Earth? So the United States planned a huge test series in the Pacific called Operation Dominic. Inside Dominic, there was a smaller program with a more specific goal. Fishbowl would detonate nuclear warheads at very high altitudes to see what they did to the upper atmosphere, the magnetosphere, and anything electronic nearby. Starfish Prime was the centerpiece of that plan. This wasn't just a science experiment. It was a Cold War weapons test aimed at understanding how space itself could become a battlefield. The weapon for Starfish Prime was a W-49 thermonuclear warhead mounted on a Thor intermediate-range ballistic missile. The Thor wasn't originally designed to shoot into space, but it was reliable, available, and powerful enough to loft the warhead to the edge of space on a suborbital trajectory. From Johnston Atoll, a little speck of land in the middle of the Pacific, engineers and soldiers built a miniature spaceport. Radars, tracking cameras, ships, and aircraft spread across thousands of kilometers. They also prepared an entire instrumentation army. 27 sounding rockets loaded with sensors, ready to launch to measure X-rays, electrons, magnetic fields, and radio signals, not just near the blast, but also at a special point in the southern hemisphere connected by Earth's magnetic field lines. The plan was ambitious. The physics? Only partly understood. Scientists had theories about electromagnetic pulse, or EMP, the powerful surge of electric and magnetic fields created when gamma rays from the blast hit the atmosphere. They expected some interference. they did not expect what actually happened. Starfish Prime wasn't the first attempt. On June 20th, 1962, the US tried to launch the original Starfish shot. The Thor missile lifted off and then failed. Safety protocols triggered a self-destruct. The warhead and missile rained debris and radioactive material around Johnston Atoll. It was an embarrassing and dangerous failure. Cleanup crews had to scrub the island, and the test schedule was thrown into chaos. But the military pushed on. A new missile was prepared. The shot was renamed Starfish Prime, and the date set, July 9, 1962. In Hawaii, the public was told to expect a brilliant display in the sky. In private, scientists and officers wondered just how big the effects might be, and whether their instruments would even survive. It's late evening in Honolulu. On the beaches and rooftops, people are waiting. Some have radios tuned to live coverage. Others just stare at the stars, curious and maybe a little nervous. Nearly 1,500 kilometers away on Johnston Atoll, the Thor missile ignites and climbs into the dark. 13 minutes later, at 909 UTC, the warhead reaches about 400 kilometers above the Pacific. There is no sound in space. No one hears the detonation. But the Earth notices. First comes an intense white flash, so bright it briefly overwhelms cameras and night vision. Then, over the course of seconds, the sky begins to glow. Witnesses in Hawaii describe an eerie greenish light spreading across the horizon, followed by a massive red auroral halo hanging high overhead. It looks like a giant crimson dome, like the atmosphere itself has been turned into a glowing shell. The display lasts for minutes. People talk about seeing the sky bleeding or a red curtain hanging over the islands. At the same time, in places like Tonga, Samoa, Fiji, and even New Zealand, observers see strange artificial auroras dancing where no auroras should ever be. For a moment, the entire Pacific night sky has been rewritten by a bomb. While everyone is watching the colors, something else happens, something you can't see. The gamma rays from the explosions slam into the upper atmosphere, knocking electrons off atoms. Those electrons spiral along Earth's magnetic field lines, creating a powerful electromagnetic pulse, EMP. In the blink of an eye, a huge electric field sweeps over Hawaii. Streetlights in Honolulu and other parts of Oahu suddenly go dark, around 300 of them. Some fail permanently. Others flicker like they've been hit by a power surge. Burglar alarms trigger for no apparent reason. A microwave telephone link between the islands is knocked out, cutting off calls. Engineers later realized their instruments were overloaded. The pulse was stronger than most of their measuring equipment could even record. No one is injured. Cars still run. But for scientists and military planners, this is the moment the nightmare becomes real. A nuclear weapon detonated in space can damage infrastructure far beyond the blast site. Quietly, almost invisibly. Starfish Prime is the first dramatic, undeniable proof. The aurora fades. The streetlights get replaced. The phone lines are repaired. It would be easy to think the event is over. It isn't. High above the Earth, the explosion has injected an enormous number of energetic electrons, on the order of 10 to the 29th power, into the magnetic field. These particles spiral around the planet, trapped in the same regions where James Van Allen's team had discovered natural radiation belts just a few years earlier. Starfish Prime has essentially built a new radiation belt on top of the old one. For months, radiation levels in certain orbital paths are orders of magnitude higher than before. And that's where the next chapter of this story begins. Because we've just launched some of humanity's very first satellites, straight into that artificial storm. On July 10th, just one day after Starfish Prime, the world celebrated another breakthrough, the launch of Telstar 1. Telstar was the first active communication satellite to relay live television between North America and Europe. It was a symbol of peaceful progress, science connecting continents. But above the headlines, invisible radiation was quietly attacking its electronics. Telstar's systems had been designed with some shielding. Engineers knew about the natural Van Allen belts. They did not design it for a man-made radiation belt produced by a 1.4 megaton explosion. Over the next months, Telstar's behavior became erratic. Its transponders failed, recovered, and failed again. By February 1963, the satellite was effectively dead. It wasn't alone. At least 5 other satellites, including the British-American Ariel 1, the US Track, Transit 4B, Engine 1, and the Soviet Cosmos 5, suffered serious damage or shortened lifespans, likely linked to the artificial radiation belt created by Starfish Prime. Think about that. A single nuclear test damaged both American and Soviet satellites, along with those of allies. Starfish Prime had unintentionally demonstrated a new kind of anti-satellite weapon, not by blowing up a satellite directly, but by poisoning the space it needs to survive. Inside the Pentagon and at research labs like Los Alamos and Sandia, the mood shifted. On one hand, Starfish Prime gave them priceless data. They now had hard evidence of how strong a high-altitude EMP could be, how it traveled through power lines and communication systems, and how radiation could disable satellites over weeks and months. On the other hand, the shot had come dangerously close to creating global problems. Planners had originally toyed with an even more ambitious test known as aurora, which would have detonated a nuclear device at around 1,300 kilometers altitude, much higher than Starfish Prime. After seeing the damage from the 400-kilometer test, that idea suddenly looked reckless. aurora was quietly canceled. The message was clear. Space was too small and too interconnected to treat it like just another test site. Publicly, the US government downplayed the risks. People in Hawaii saw the strange lights and heard about the blown streetlights. But the bigger strategic implications, the satellite failures, the artificial belts, were discussed mostly behind closed doors. Many of the technical reports on Starfish Prime were classified and only released decades later. Still, word leaked out. Scientists around the world expressed concern. If one test at 400 kilometers could do this, what would multiple tests do? What if other nations tried similar experiments? And in the shadow of the Cuban Missile Crisis, political leaders on both sides were suddenly very aware of how close the world had come to catastrophe. In 1963, just a year after Starfish Prime, the United States, the Soviet Union, and the United Kingdom signed the Partial Test Ban Treaty. The treaty banned nuclear tests in the atmosphere, underwater, and in outer space. Starfish Prime wasn't the only reason that treaty existed, but it was one of the clearest, most alarming demonstrations of why tests in space were simply too dangerous. Today, Starfish Prime is a case study. Military planners use it as a model for worst-case EMP scenarios. How would a high-altitude nuclear blast affect a modern power grid packed with sensitive electronics? What would it do to fiber backbones, satellite constellations, GPS, aviation, and the internet? Space scientists still study the data to understand how energy moves through Earth's magnetic field, and how both solar storms and human activity can shape the radiation environment around our planet. And satellite designers use lessons from Telstar and its unlucky neighbors to determine how much shielding and redundancy modern spacecraft need. There's broad agreement on one thing. no responsible government wants to repeat Starfish Prime today. Our world is vastly more connected. We depend on satellites for navigation, finance, weather, communication, and military coordination. A similar test now could damage systems far beyond any single country and potentially trigger conflicts no one could control. Looking back, Starfish Prime feels like a paradox. On the ground, it was marketed as a kind of cosmic fireworks show, a spectacle for tourists on Waikiki beach. People remember the beauty, the green flash, the red halo, the strange artificial aurora hanging over the Pacific. In orbit and in the power lines, it was something else entirely. A silent electric punch that knocked out lights and phones. A flood of electrons that slowly killed some of our first space machines. A human-made scar across the invisible architecture of our planet's magnetic field. For a few minutes, the sky looked magical. For months afterward, instruments quietly recorded the cost. Starfish Prime proved that in the nuclear age, the battlefield isn't just cities and bases. It can be the sky, the magnetosphere, even the orbits where our technology lives. In the end, Starfish Prime didn't start a war, but it forced humanity to look up and realize just how fragile our space-age infrastructure really is. A test designed to protect against enemy missiles ended up damaging our own satellites, our own networks, and helped convince world leaders that some lines shouldn't be crossed again. Next time you rely on GPS, check the weather on your phone or watch a live broadcast from the other side of the world. Remember that in 1962, a single flash in space almost broke the rules of that invisible system. If you enjoyed this journey into one of the most dangerous experiments ever carried out above our heads, hit the like button, subscribe to Untold Atlas, and tell us in the comments, what other forgotten Cold War experiment should we explore next? Because history is full of moments like this. Tests, accidents, close calls that quietly built the world we now take for granted.